Thank you very much. So my presentation today is going to be a fairly rapid run through of something that can take much longer. And so I suspect there'll be a lot of questions afterwards. And I think it's great that it's being recorded. I'm quite familiar with the nature of the limits to growth policy and the water allocation and bump up against those water allocation limits. And so I will probably start by sharing my screen, running through my notes on my screen, and I have given just a PDF file to Laura to share with anybody that wants to have those slides afterwards. And Laura, when my screen is being shared, I won't be able to see, I don't think, anybody's hands up, so feel free to interject at any time to ask a question.
Sounds good.
So, let's go. And I'll go to my PowerPoint here momentarily. And does everybody see a full screen? Perfect, I see thumbs up. So to start, I'm going to basically today just be doing a high-level covering of some of the concepts, the policies, and the standards that are used. And with that, we'll be touching on some of the things that will impact the individual residences in Tofino that are looking to basically get a building permit, for lack of a better term, or get in a subdivision allocation or do a rezoning, as well as touching on the base of if you have a restaurant or any sort of public facility, what I call industrial, institutional, commercial applications, be touching on how that is also managed through the rainwater policies that exist. Personally, I've designed over probably 50 designs, covering everything from Terrace and Nelson, mostly in the southern Vancouver Island. I do engineering design for engineering firms, though I'm not an engineer myself. 90% of my stuff is single-family residence and mostly focused on potable water design, and about 10% of it is what I call ICI, which is industrial, commercial, or institutional. I've been involved, did the design up for the Discovery Montessori School in Nanaimo, which was the first public potable rainwater system in Canada. And so I have a broad experience as to just the needs and the requirements that cover individual residences right on up to public systems. So back in 2018, there was a Canadian standard that was designed. There's actually it was the very first actually co-design standard between Canada and the United States. So the Canadian standard is called the CSA B805 National Standard Rainwater Harvesting Systems. And it is the defining standard that influences not just how we design a residential system, but it also influences the design of public water systems. With that, it's what engineers would use to make the case as to how treatment occurs, what materials are used, how to size a system. And one of the really important things within the Canadian standard is it breaks water end use up into 4 different tiers. When I say water end use, you've got potable water end use would be anything that is going to come into contact with your mouth, whether it is for food preparation, drinking, or showers, or even bathing. But there's also 3 tiers below that, tiers 1, 2, and 3, which look at non-potable water use, and the tiers are based on what is the potential risk to people and the potential consumption of the water, and each of those tiers has a different treatment level that is required. We're going to basically be talking about tier 4 today, which is the highest end use, which means that we have to treat it for potable standards. back in 2020, the province has actually been pretty forward thinking on the use of rainwater for potable use for quite some time. It does take the province a little bit of time to act, but the couple things that I have worked on with the province and been involved in, I find that the province has always been quite proactive. And back in 2016, the province came out and pushed for the update of their sewage system regulations to allow gray water systems and composting toilet systems. And then in 2020, the province has pushed forward with bringing in the design guidelines and the treatment guidelines for using rainwater that's harvested for potable use. The province works under something that's called the Drinking Water Protection Act and the Drinking Water Protection Regulations. And what the province does, the province then delegates the authority of upholding those regulations to the health authorities in the province. And in our case, our health authority is the Vancouver Island Health Authority. The other tool that the province provides, and they provide this to the health authorities or the drinking water officers that work for the health authorities, is a drinking water officer's guidebook. And that guidebook is very lengthy, and it covers everything from shallow wells, surface waters, deep wells, and it provides all the treatment objectives. The one thing that is interesting when it comes to the Drinking Water Officer's Guidebook, or the authority that is given to Island Health, when it comes to a water system, if you look, there's one water system that is exempt from the Drinking Water Protection Act and Drinking Water Protection Regulation, which means there's one system that Island Health doesn't get involved in. And that is the most common system I run into, which is a single family residence. The way that the regulation is put forward is that the Drinking Water Protection Regulation and Island Health's involvement is for any system that has two connections or more. And what that means is if you have a house and you have a detached accessory dwelling unit or a detached suite or a granny flat or something else, if you have one water source, but you have two distinct connections going to two different buildings or more, then it becomes something that is regulated by the province through the Drinking Water Protection Act and Drinking Water Protection Regulation. I'll be talking a little bit more about that in a bit. But if you have a single house or a single house with a suite in it, then you are exempt from having to go through Island Health. What that means is it puts it into, if you're going to do a rainwater system or a surface water system off of a lake or river or shallow well, you would have to go through your local government, and they would set certain bylaws, policies in place. The other two things that pop into play are the BC Building Code and the National Plumbing Code of Canada. The province of BC recently turned to relying on the National Plumbing Code of Canada as its official plumbing code. So it used to be the BC Plumbing Code. There is confusion in the way that people interpret these codes. The BC Building Code doesn't actually state what source water is allowed to be potable. They only speak that potable water is required for certain applications. And so the BC Building Code is silent on the actual source of source of well water or surface water or rainwater as the allowable water source that's serving the potable needs for a residence or a building. The National Plumbing Code of Canada is oddly, it does talk about potable water, but it doesn't talk about the source. What the National Plumbing Code does have is they do have a section for rainwater that is treated to a non-potable standard and what those non-potable uses could be. And it's really important that just because the National Plumbing Code speaks to the non-potable use of rainwater they're not actually saying that rainwater cannot be used for potable. And it's a bit of a misconception sometimes that I see across building officials as they come to grapple with some of the things that they're faced with. And I'm going to probably, I put this in here as sort of my interpretation of the most appropriate interpretation is that the National Plumbing Code's non-potable rainwater harvesting section speaks only to that rainwater that's treated to the non-potable standard can be used for particular non-potable uses. Because it is quiet on the potable sources of rainwater, the fact that we actually have the Drinking Water Officer's Guide that speaks to the treatment and allowance of rainwater for potable uses, we have Canadian standards, is that in BC, province does look at rainwater as a suitable source of potable water, just as it does with shallow wells or surface water or deep wells. And so it's just really important to recognize that it's not the building code or the plumbing code that dictates what the water source can be and is suitable for potable water. Otherwise, we'd have a lot of people that would not be able to use wells in the province of BC to serve potable water needs for either their homes or their businesses. When it comes to the single family residence, so when we're not talking about the health authority's involvement in a water system and we're looking at a single family residence, it becomes the local government that has a jurisdiction of authority to allow and navigate and come up with some of the requirements they want to see for the ensuring of safe potable water. And before I sort of dive into this, one of the things I will say is that there's a lot of small, I think they've got like 168 municipalities within the province of BC. Some of them are really big, Metro Vancouver, Victoria, the Capital Regional District, which is a large regional district, the Regional District in Nanaimo. These are all local governments. They have staff that they've got a broad variety of staff that come with a variety of different skills and training. So it's not uncommon to see larger municipalities that have staff that can navigate their understanding of water system designs. But for the most part in BC, and I think about my own community, we have 2,600 people that live in our community. We have one building official who is also the bylaw enforcement officer. And I think about Tofino, you have good staff, but you don't have the broad complexity of staff or the resources where they have the ability to necessarily understand the engineering or the requirements or the different the Drinking Water Officer's Guide. So they really rely on another means to ensure that if a system is going to be used, it's important for them to know that it's safe. And so they rely on something that's called the professional reliance model, where they're requiring an engineered stamp plan usually to give them the comfort that all the I's are dotted and T's are crossed. So with that, a local regional government can use a variety of different tools to regulate aspects of rainwater use, such as development permit areas, and probably the most common one is seen within the Regional District of Nanaimo and their Yellow Point Aquifer Protection DPA, where if you're doing a building, you have to have rainwater collection. They don't state what you can use that rainwater for, but you have to have a certain volume of collection at Yellow Point. Within the Capital Regional District, the area that I am, which is, it's 13 municipalities from Victoria, Sault, North Saanich, so on. Capital Regional District has a building bylaw wherein it has evolved over the years because they've had to evolve it. They've got all the Southern Gulf Islands involved in the region, and there's many places in the Gulf Islands where there just isn't the groundwater to serve a house or a business. And therefore, they've had to bring in a bylaw that now actually has the requirements, what they need to allow a building permit to move forward, but they also have put a bit of an incentive in there, some minor incentive, but if you are going to be putting in a rainwater system within the CRD, and the CRD is involved in the permitting process, the CRD will actually reduce the price of the permit to help offset a little bit the design costs that are involved in the rainwater system. Main Island has an interesting approach. It's a little bit of a flexible approach to their housing zoning. So I guess it was in 2024, the province made a big push towards allowing multiple accessory dwellings, whether it be inside a house or in an exterior building. And we didn't, communities, whether they wanted that or not, that's a different story. Some communities did, some communities didn't, but it meant that pretty much everybody was at least allowed to have a secondary suite in their house or a secondary accommodation on their property. With Main Island, the way they've approached it is that if you want to have a secondary suite, you can only get it if you put in rainwater collection of a certain storage sizing. And so Main Island has a slightly different approach. Again, they don't suggest how it's used, whether it's for potable or for non-potable. The most recent one I did on Main Island was just to service the laundry and the toilet flushing. So it was a non-potable system. And then other areas, other regions, we'll see different policies happening. In Vancouver, they have a city-wide rainwater management plan. So it's a guide to help promote more rainwater capture and stormwater management. Metro Vancouver has created the non-potable water reuse guide. So it's non-potable focus, but it's certainly focusing on developing a policy and some guide documents to make it easier across the region. That was a project that I had worked on a couple of years back. So there's many different approaches. And I think when it comes to Tofino, probably the most likely approach would be to do what the CRD has done. So residential systems versus small water systems. I'm going to go into this a little bit more in depth. So I've introduced residential where we have one water source, and I'm not going to differentiate whether that one water source is a well or a rainwater system or a lake or a river. This is strictly based on what the province has under the drinking water regulation, because there's multiple different sources they allow. But it comes down to if you have a single water source that you're pulling water from and it's serving one house with one secondary accommodation inside the house, then it's going to be, in your case, Tofino that would have jurisdiction over it. It's going to be that local government. And the design standards that apply include the Canadian standard, the National Plumbing Code, the BC Building Code, and the Canadian, the Guide for Canadian Drinking Water Quality. So the GCDWQ is basically the requirements, the water requirements that are having to be met after treatment to ensure that it's potable. If you have a property, and if you have a house and you have a detached dwelling unit on site, or you have a house and you have a couple of rental cabins, if it's a bed and breakfast, or it's a public building, commercial lodging, restaurants, then you fall under the drinking water protection regulation, and you have something that's called a small water system. And in a small water system, what occurs is it is the health authority that then looks at the design, gives you your construction permit to build the system. They're the ones that come in and do the review, make sure that it's been installed properly. Then they sign off on it. They give you an operating permit, and in that operating permit, what they tell you is what you need to test for and how often you need to test your water. And so it follows pretty much the same design standards included in residential, with the addition of some additional design standards from the Drinking Water Officers Guides. That's the DWOG that I have underlined in that lower box. And it also relies a lot on some of the standards in the Environmental Protection Agency's design guidelines for surface water treatment. I don't have the number, the EPA number there, but it's referenced within the Drinking Water Officer Guidelines. So we have a couple of additional things that we have to design for in a small water system. One of the main differences for a residential system and a small water system when it comes to rainwater is when it comes to a small water system and rainwater, we have to have two different barriers of disinfection, which means that in a residence, we'll need to filter down to a certain level. We'll need to give a UV dose of a certain dosage level, 40 millijoules per centimeter squared. With a small water system, that gets upped a bit in the sense that we also have to have chlorination. So if you are running a house with a secondary detached dwelling, you're going to have the same system from a residential perspective, but with the addition of a chlorination unit, unless for some reason the health authority says it's not required. I have never run into that yet. And I'm just checking to see no questions. I'm going to continue on. So when I think about Tofino and I think about the size of the administration, the staff I've talked to are excellent. They have a lot of concerns for the residents. They're trying to do the best thing for them and also work within what their constraints are. Because really, every municipal government could always use more staff, and they could always use more funds to fund consultants and things like that. But that also means higher taxes, and that's something which also is not necessarily a desired thing to see in a region. So the local government, the best practice is you could have a design. The design has to be stamped by an engineer. And so you'd have someone who is a non-engineer. It could be a homeowner. It could be someone like me that is well-versed in rainwater system design. And they would send the design and the water safety plan to be reviewed by an engineer. The engineer would stamp those plans. That gives the professional reliance, that gives the confidence to the local government that it has been reviewed, and also that the liability has been passed on for the most part to a professional, the engineer and the designer. Within any professional prepared plans, and the plans that I do and the ones that occur in the CRD, is we all not only have our designs, our diagrams, we also have a written water safety plan. And that safety plan covers about 7 different things, but some of the most important ones that stand out is you have such things as a site assessment, a risk and hazard assessment with what the mitigation measures are going to be. You look at the land use. So in other words, I look at the OCP designations and I look at what the future impacts could be on a property. So for example, if a property is in, say, an area where there is a commercial OCP designation on a property that presently is not commercial, it means that there could be commercial or industrial activities that might be allowed next to a water system that, if a water system were to go in today and we had a manufacturing or processing plant that went in next door, 10 years down the road, it would really impact what the water treatment system would be able to handle that was allowed much earlier. So I think about, I think Crofton Mill has been in the news lately. We've heard the bad news of them having to close down. But to put it in perspective, on the north part of Salt Spring Island, the airshed, because of Crofton Mill and what comes out of Crofton Mill, the airshed that serves North Salt Spring makes it that you can't really properly have a potable water system in North Salt Spring due to the contaminants that come from Crofton Mill. That is something where we can see that present now and here today. But if people were put in a system on North Salt Spring, Crofton Mill didn't exist, but Crofton Mill was allowed in the OCP to exist in the future, and it came in, you'd have a potable water system that probably could no longer be a potable water system unless a very different type of treatment system were to go in to deal with the contaminants. With the engineered stamp plans, what the engineer also does, and this is what we did with Lorraine and Doug, is the engineer has to provide the building official a Schedule B, and then when everything has been completed, Schedule BC, I think I've got it backwards here on the slide. And what that does is that gives the assurances to the building official that the system has been designed to professional standards, to good engineering standards. And then when everything is completed, it means that it has been reviewed and confirmed that the build out of that system has been done to those professional standards, and it has been completed and approved by the engineer. And that's usually accompanied by a water test. So that is something which then also gives the local municipality the comfort that everything has been done properly. And even though it's not required as part of the engineering side of things, one of the best practices is also to have a user's manual. And I've come across a lot of systems where there hasn't been a user's manual that has been completed for a system. But the way I look at it is if I designed a system for Lorraine and Doug, and I didn't give them a user's manual, one, I'd be having a lot more phone calls from them. And but two, if they ever decided to sell that system, the system that might make sense for them because they were there when it was built, it comes to a new person or a new owner, and that system no longer is something that the new owner may understand. So what might be an asset for the present owner would become a liability for the new owner, and would actually be a disincentive to the resale of a house if there is no documentation, because someone's asset becoming someone else's liability means the value of that property would probably go down. So a user's manual actually is beneficial to maintain the asset value of a rainwater system. And the other thing is that upon completion of a system and upon commissioning, the water tests are done to ensure that the raw water and the treated water meet certain guidelines. And so the raw water is compared to something we call the BC Source Water Quality Guidelines. And then the treated water is the the guidelines for Canadian drinking water quality. And with that, that is probably about a $800 cost to have those two tests done, about $400 a piece. But that is what allows the engineer to stamp off on a system. So those are sort of the best practices that are involved, and where it gives the most insurance to the local authority, but it also gives the most insurance to the people that are drinking water, because I don't think anybody wants to necessarily drink bad water. Some of the things that would be making up a plan are going to be, the first thing is going to be a water budget. So anybody that comes to me that wants to consider even doing a rainwater harvesting system, what we're going to take a look at, the first thing that usually happens to me is people will come and say, hey, how much does it cost? Or can you design a rainwater harvesting system for me, and how much is it going to cost? And I'm going to say, hold on a second, I can't do that until I do a water budget. And so what I'm going to do is I'm going to take a look at the size of the collection area, what the footprint is of the roof. I'm going to take a look at the precipitation data. And normally I am looking at precipitation data that is based on the climate change projections out to 2050. And I'm going to be looking at the worst case climate model, which is RCP 8.5, because that's really, I guess, where society is going. And so we take a look at the worst climate predictions out into the long term. We also take a look at daily demands. We look at what water is going to be used, how many residents are going to be in the building. We need to take a look at what backup supply there's going to be. And if there's no backup supply, then I usually add an extra 15% sizing onto the capacity of this system to make up for a potential lack of supply. And at that point, I can then design the size of the storage. And generally, the storage is going to be about half the price of the system, slightly under half the price of the system. What I'm generally seeing in terms of the price of a potable water system for a new residential build for a house of the average house is in BC, I think is 2.6 people. My son is not 0.6. I think my son is about 1.6 in terms of the size. So average price is going to be about the $45,000 to $55,000 range. And the things that have an impact on the price variability is going to be one, where you are located. So in Tofino, because it rains more often, your storage system can fill up quicker and more rapidly and more often. So generally your storage sizing is going to be half the size of what would be needed for the same house on Saturna Island. The other thing is that in Tofino, because you have a lot of rainfall, you would find that you can get away with a smaller roof size, whereas in Saturna Island on East Point, which is in the rain shadow of the Olympics, is they have to have more roof space and more storage capacity. So it's going to be more expensive on Saturna Island than it is in Tofino. Bedrock has a big impact, the use of gravity. If you've got no possibility of having any water delivery or top up from a well, then you do have to slightly size your system bigger, and that means more storage capacity. So there's going to be a variety of different things that can impact the price, but the water budget is the starting point. And I mentioned about risk, hazard, and mitigation. So when a design is being done, we need to assess the materials. A lot of people that are doing systems themselves will tend to use the cheaper materials. And I will say in particular, for bringing potable water into your tanks, it needs to be an NSF 61 or a potable water certified product piping. And because of the size of the piping, usually it's 4-inch Schedule 40 PVC, which is really expensive. It can be upwards of about $15 a foot. It's much more expensive to use the proper materials than it is to use the PVC sewer pipe, which is about $10 a length of 10-foot pipe. And so the materials is one of those things where we have to be quite critical about it. And people are a little bit shocked. Plumbers are shocked. The mechanical contractors are shocked, but it is the materials are very important. Roofing, for example, is pretty standard because a lot of people are moving towards metal roofing, and metal roofing is exceptional. And the two products that are used in our area are coated with coatings that are potable water rated, SMP and PVDF coatings. So it's not really, you don't have to work too hard to find a roofing system that meets that. If you're dealing with a flat roof like Lorraine and Doug, they used a TPO roofing material, which also meets the criteria under the Canadian standards for potable water collection. That being said, if you do have a roof material, you've got a roof, you're doing a retrofit, or you've got a house that's going in and you're deciding to put a rainwater system in after the fact, and the material you've chosen on your roof is not to standard, you can get very easily coatings that can go on to roofing materials that are NSF 151 rated or rated for potable water, rainwater harvesting. So it's not hard to navigate that if there's been an oversight earlier on in the design process. I already talked about the site and looked at the potential hazards that could come from looking at future land use designations that are close by, so I won't go into that. People impacts is really important. And I've got a house out in behind Cypress Bay that I did probably 12 years ago, maybe even longer. They have got a great air shed. But what they also have is they have a salmon, they've got the Cypress River close by. And so they've got the salmon spawn that happens. And so even though they've got a great air shed and not too much issues with tree pollen, what they do have is a very short period of time where they have a lot of bird poo on their roof. And so we had to design a treatment system that could handle the additional bird poo. So we take a look at the seasonal impacts. And one of the things that's become more common, certainly in the Gulf Island areas, is the amount of wildfire smoke when they have our big smoke events. And when we get to a certain air quality index that's bad, we need to put in a diverter so that if there is a rainfall, the roof is rinsed off and all the contaminants that are in the air that get washed out by the rain are sent off to a drain so that we're not collecting the worst of the contaminants off the roof. The other thing we have to think about is chemistry. And Nanaimo, oddly enough, has a very low pH in their rainfall. When we did the school in Nanaimo, we actually had to soak materials in the rainwater for a month to see what was leach out. And so I think we had a pH of our rainfall that averaged about 5.2, so quite a low pH, quite acidic rain. And air quality goes back to the site and other pollutants. Some of the other things that are part of the risk mitigation would be looking at where your sanitary infrastructure is and making sure that you've got proper horizontal separations. And that's also something that can often be overlooked in the initial design phase. But you'll see a list off to the right, and that basically gives you what your possible contaminants are, what the likelihood exposure is, and what the mitigations are. And there's going to be several mitigations throughout the system to try and deal with the risks and hazards. One of the big things that's really important for the local municipality is to, and I think about Tofino in particular, certainly in the CRD, it's a big issue. When we have a municipal system, a lot of money goes into treating the water, and the last thing we want to do is to have water that potentially may not be treated backfill into or back up into the municipal system. So we need to have something that's called cross connection controls. And in pretty much all the systems I do, whether someone has a well or someone also has a municipal system that tops up their cistern, is we use an air gap. And that means that the tank can fill up to a certain level and it starts to overflow. And if you have top-up water that comes into your tank, there needs to be an air gap of a certain distance that ensures that when your tank is at its maximum height, it doesn't come into contact with the outlet of the valve that is topping up your tank. So the air gap is 100% foolproof. The other thing that's really important is if you have a municipal service coming into your property, that you have something that's called a DCVA or a double check valve assembly. And anybody that has an irrigation system will already have one of these. Certainly within the CRD, as part of our cross protection control bylaw, is that if anybody has an irrigation system just after the service meter, they have to have a double check valve installed, and it has to be inspected yearly. And usually any plumbing contractor will have someone on staff that has gone through the certification process to do the yearly inspections. It's a pretty straightforward thing. But the whole idea is that if anything were to happen, water can't flow back into the system. And it sounds kind of crazy, but in our area many years ago, Saanich was flushing their pipes out, and they got a call in that someone had hair coming out of their tap. So Saanich went out, and so they decided to flush the system again, thinking they hadn't flushed it well enough, and more people called in and said they had hair coming out of their tap. What they found is that someone was doing some backyard tanning. They had a hose going into a kid's pool, and when Saanich was flushing and they were creating a back pressure or a vacuum pressure in the lines, it was sucking water out of the tanning fluid and bringing it into the Saanich lines and pushing it down the street. So double check valves stop that sort of stuff from happening. The one thing that was quite novel with Doug and Lorraine's place was putting in a municipal bypass. This is not something that we normally see. This was an interesting way of approaching providing municipal water if the rainwater system went down. So normally we would just bring the municipal top-up water into the cistern through the air gap, and if there wasn't enough rain, then if the tank got low enough, the water could come up and fill up a partial amount to maintain a certain baseline level of water in the cistern. But if for some reason, say Doug Lorraine's tank was contaminated, or something went south with the pumping system that was pumping the rainwater, the municipal bypass would allow them to bring water in under municipal pressure and supply the house until they're able to rectify any issues that they might experience with their rainwater harvesting system. And with that municipal bypass, the engineer I work with, we came up with a system that would allow us, and a process that would allow us to safely ensure that we could bring water in, bypass, and not potentially contaminate and have to put the double check valve of the city to into practice. And so we did put a municipal bypass system into Doug and Lorraine's house, and an instructions that it's located right by the bypass to make sure that if they ever have to use it, it can be used. And with design drawings, you're going to see a whole bunch of different things, not too different than house drawings. You're going to see plan drawings like what you see in the top portion here. And those plan drawings will include the tanks, the site layout. And here we've just got a picture of the tanks. We've got the blue piping is everything that has to be the water rated. The yellow piping is everything that can be sewer pipe rated. So it doesn't have to be, it can be cheaper pipe. Doesn't have to meet the potable water quality standards, but you're going to have designs that specify the size of the pipe, the type of materials, and any of the other aspects that are important. One of the things which is really important in a rainwater system, which often also is overlooked when people are doing themselves, is that when you have two or more tanks connected together, the connection between the tanks needs to be flexible. Because as the tanks settle over time and the walls expand and contract, if you do not have a connection that is flexible between the two tanks, you can often get some sort of failure, and that can lead to a loss of water storage in your tanks. But also get elevations, so looking at the elevations of your piping, elevations of where your tanks sit, your top-up valves, those are also a part of the design drawings. And depending on the time, I can pull up the PDF of Doug and Lorraine's system and just quickly scroll through their design. So we have water systems, just to reconfirm that anything that is a small water system, such as a house that's two connections, but that second connection is to an exterior living unit, would fall under a small water system. And or if it's a community water system or a public, industrial, commercial, institutional. Again, a similar design process, but there's more detail to it. Usually the design process for a residential system is going to be about $6,500 to $7,500 for the design for a single family residence. You're usually looking at about 8 to 10 for designing a small water system, because is more design work and more detail that Island Health requires. On the upside, Island Health has two very good public health engineers that work for them. One of them is located in Port Alberni, Morgan. Morgan and Daryl are exceptional. Island Health is exceptional uh, because they have a high, because they are engineers. If I do a design that is for a small water system, Island Health doesn't require me to get the engineering stuff stamped and designed. They will look at it, and I think the last system I sent to Island Health was for a resort, small or a retreat area, and from the time they looked at it to their approval, it was 5 days, and there was no changes or additions. So they were really efficient in it. They understood it. They were happy with it. But the detail that I had to put into all the applications and the forms was much more time on my part. Probably double the time goes into my time on an island health system than on a residential system. But I don't have to have the engineer to review and stamp it off. And Island Health is the one that is involved in giving the construction permits, the operating permits. They do the inspection and they set up the operational requirements, such as the water sampling frequency. A user's manual is going to cover basically each of the main aspects of the system, and it's going to talk about a component of the system, a description of what it does, what the operations and maintenance of it are, and also when it needs to be serviced. And so any owner's manual should be pretty straightforward. This is Doug and Lorraine's a part of their owner's manual. In their user's manual, they also have sort of photo documentation of the different components so that they can take what they see here on this screen and ensure that they can find it in the picture of their owner's manual and to try and make it quite simple. So a user's manual is usually about 6 pages or so. And it also includes a logbook of any maintenance or upgrades or filter changes that might occur. But a user's manual is pretty important. And I think it is probably one of the most important features to make sure that this system is useful for anybody else in the future that has to own that system.